Thanks for asking the question. I'd be happy to answer it. And the best way is probably just to walk you through it by drawing a little picture of it. So I believe this is the question that you were asking about. And it gives us information here about how far our solar system is from the center of the Milky Way galaxy. That's going to be our radius. So if this is the center, we've got our Milky Way over here. I'll just do WM for Milky Way galaxy here. This distance right here is the distance at which we're orbiting. This is our radius to the center for the orbit Milky Way going around the center of our galaxy. And it says 1 light year is the distance light travels in 1 year. It gives us the speed, and we're 25,000 light years. So this is equal to 25,000 light years. You need to convert this into a distance. So take the distance that light travels in a year, so calculate the time in a year, multiply it by this velocity, and you'll get the distance it travels in 1 year, multiply that by 25,000, and you'll get the distance from our Milky Way to the center of the galaxy. And that's your radius in meters. Assuming the orbit is circular, what's the period? We want to know what t is here, and t is equal to 2 pi r over v. And that's on your AP equation sheet, the definition for period. It gives us the velocity here, so we know this. You just calculated the radius, right, converting that into meters, and you can calculate that period. The period will come out in seconds because we're going to be kilometers over a second. This needs to be converted into meters per second before we plug it in here, so that our meters cancel. So our radius is in meters and our velocity is in meters. And then our period will come out in seconds, convert that to years, and you'll have your answer for your first one. Divide 5 billion by that answer, and you'll get how many orbits it's completed in that time period given. And then the second part here, the gravitational force exerted on the solar system is the net force due to all the matter inside our orbit. It's saying consider all of the objects inside here as one big spherical mass. So there's more than just one mass. There's all sorts of things in our galaxy going through there, or in the universe inside of our galaxy. And they're considering all that one giant star. What's the approximate mass? How do I calculate that? Well, you have a velocity here. I'm going to switch colors for this part. So I've got this velocity given to us in the problem, and there's a force that pulls towards the center here. And this force, if we're going to stay in orbit here, this is our centripetal force. Well, the centripetal force has to be equal to mv squared over our radius r. Well, we know v, and we know our radius r, and the mass here would be the mass of our Milky Way galaxy, which you don't actually have to know to solve this problem, because this force has to come from the gravitational force. So I can also say that this force is from force of gravity, and the force of gravity is big G times mass of our Milky Way times mass at the center, I'll call it mass C, divided by the radius. And we have the radius here, and we do radius squared. So these two equations can be set equal to each other. mv squared over r equals g m at the center, the mass at the center, over r squared. Well, the mass of the Milky Way galaxy is going to drop out of here, and you know what this value is, the v. It's given to you in the problem. You know r, we solved that earlier. We know r here, and we know what big G is, so we can solve for what that mass at the center must be, and that'll allow you to answer the last two parts there. Hopefully that helps. If you still have questions, feel free to send me an email, and I'd continue to help you on this problem.